Hey guys, here's my Philco 643. If you recall in an earlier video, I finally scored what appears to be an intact chassis for this set, and I think I just scored a speaker for it. Here's the speaker that I found on eBay for a whopping 99 cents. I was actually the only bidder, which was a little surprising seeing as how much bidding there was on the chassis. Also, this looks like it's in really good shape. It hasn't arrived yet, but I'm hoping it will make it here safe and sound. Here's the back side. You can see that large permanent magnet that it has rather than a field coil. Now this is actually for a Philco 624 farm set, which runs on 6 volts and has a vibrator to make the high voltage, just like a car radio does. But I pulled up the schematic for it, and it looks just like the 643. They both have a 30 driving a 19, center tap transformer, and then the speaker. The part numbers don't match though, but I'm hoping it's close enough that it will work all right. So here's the 624, and here this is 643. So as you can see, quite similar. So I'm hoping that will arrive later this week, and I expect I'll start working on the chassis before too long. And I'll also have to make a battery eliminator before I can even power this set up. But in the meantime, I want to start working on the cabinet. I actually did refinish this cabinet already. In fact, I think it was the very first cabinet that I ever did refinish. And I'll be the first to admit that I didn't do a very good job. Primarily because I used stain and not toner lacquer. See, the sides, the top, are actually supposed to look like this, which is extra dark walnut toner lacquer. And it's the opaque kind of lacquer, so it actually hides all the grain. Whereas in mine, of course, you can see the grain. So what I'm going to do is strip this down, which should be really easy because I just use Watco lacquer and it should just melt right off. And then I'm going to use grain filler and toner lacquer and try to do a better job on it this time around. I did preserve the original decal when I did this the first time, but since then I've secured some reproduction decals, so I don't mind taking this right off with the stripper. If you're wondering why I'm jumping in and doing so much cabinet work, well, I can't do much refinishing during the winter, and it's going to be brutally hot all week, and I can't take being in my workshop and soldering for very long. And actually it's going to be too hot probably to spray lacquer, but I can certainly do stripping and sanding while it's hot. I'm using the Zinsser citrus-based gel stripper. Simply pour it on, smear it around, and wait for the finish to dissolve. I imagine it won't take too long, 15, maybe 30 minutes. It's been about half an hour, and as I hope, the finish is just coming right off. I just use paper towels or these shop towels to get the stripper and it'll finish off. I've also heard that wood chips, like for hamster bedding, are a good thing to use, or rags, whatnot. Some guys use steel wool, but I'm not crazy about that because you end up going through a lot of steel wool because it clogs up really quick with all the stripper. Alright, I finally got off all the stripper gel. Then I went over it a bit with some steel wool and this Minwax furniture refinisher to remove any more traces of the old finish. And now I'm going to go over it with stripper wash. It's very important to neutralize any remaining bits of stripper before you move on. Alright, I finished with the stripper wash, and now I'll let it sit overnight to let all the solvents evaporate. It's been a few days since I stripped the cabinet and all the solvents seem to have evaporated. Now I just have one repair to make. I've got it facing front down on my couch right now, and the brace on this side was really loose. See, the sides are made out of plywood basically, and it's not very strong, so to reinforce it they put an extra strip of wood along the side here, and the one on this side was not only loose but actually a bit short. It should extend all the way down to the end there, and it doesn't. So I carefully used a razor blade and a putty knife and worked it loose. The only glue that was holding was right in the middle here. And now I'm going to use this piece of oak and cut a new brace. Just need to cut it to the right length, and then I'll glue and clamp it in place. That piece of oak worked out great. That side is nice and strong now. I'll be painting it dark brown to match the rest of the inside of the cabinet so it doesn't stand out so much. Now, as for the rest of the cabinet, the sides and the top are made of this walnut plywood of sorts. I assume that they bent it with steam to make these curves. It's pretty tight grained, so I don't see any need to use grain filler on it. In fact, I think the grain filler wouldn't really accomplish much. It would just all wipe off. But it's not perfect, so I do need to seal it and do a bit of filling on it. So what I'm going to use is some clear shellac. Dries quick, easy to apply, and it's completely compatible with lacquer. Don't use this under polyurethane, no. They have a separate type of sealer for polyurethane. As it says, easy to apply, dries in minutes. If you've never used this before, it's a natural product. The solvent they use is actually grain alcohol, I believe. It actually smells quite a bit like beer. And to clean it up, I use denatured alcohol or ammonia. I'm just going to put it on with a foam brush. And according to the directions, you should let it dry an hour before sanding. I'll probably need 2 or 3 coats, so it'll take me 2 or 3 hours, I guess. It may look really yellowy and nasty, but it does dry clear. Here's what it looks like after a few minutes. As you can see, nice and clear. In fact, you can use this as a finish coat if you like. It certainly is a traditional finish that was used pre-lacquer. I'm also putting it on the feet and around the back. Traditionally, they didn't really finish the unseen surfaces, but I like to put a little bit of something on these back surfaces just to help preserve the old wood. You know, I'll do the bottom of the set and so on. Putting it on is really easy. Just get a little bit of a brush. Like so. Very little odor, dries real quick, real easy to clean up. That's why I like using this stuff. Especially when it's a really, really hot week like it's been and I'm working inside. Don't want to have a whole lot of fumes or I'll be dying in here. Alright, that's one coat down. I also put the shellac on all the trim as well. I slopped a little bit on the front here and there, but that's not a problem. The grain filler will go right over that. You know, I have actually seen people sell radios that look like this on eBay and other places where they just stripped down the cabinet and then clear coated it and sold it like that. It may look okay, but trust me, it'll look much better once the toner lacquer is put on. I went through about 4 rounds of painting on shellac and sanding it down on the sides and the trim. It's nice and smooth now. All the voids have been filled in. So next up is the center panel. For that I am going to use some grain filler. In particular, this Constantine walnut paste wood filler. This is the first time I've opened this can, and it's separated quite a bit, so I'm going to have to stir that up to a nice even consistency. And I'll put a small amount in this cup and thin it further with some mineral spirits till it's like a heavy cream consistency. and then I will be working it into this wood surface. I got the grain filler all mixed up, and now I'm applying it with a small brush in circular motions to make sure it gets worked into the grain really well. But as it starts to get cloudy, as it is in some areas already, I'll use some burlap to wipe off the excess going against the grain. The grain filler is dried enough that I can start rubbing off the excess now, so I've got to scrap the burlap and going carefully against the grain. The idea is this grain filler is kind of a sludge of silica particles and pigments and whatnot, and you want to work it in and fill in all the pores of the wood, but you don't want to wipe out too much, well, otherwise it won't be nice and smooth, so that's why you go against the grain. It's a little bit hazy, that's alright. As this dries even more, I've got some cheesecloth that I can wipe with the grain, and I can always do a little bit of sanding after it's completely dried, which takes about 24 hours. Alright, so far so good. Now I have to wait 24 hours for it to dry. I'm putting together an order at Renovated Radios. They sell a lot of great reproduction items, including, I think, some reproduction rubber mounts for the tuning capacitor on this chassis. There's 3 of them, 2 in the front, 1 in the back, and they're rock hard, which is making this tuning capacitor really loose. But before I can order them, I need to measure them to make absolutely sure I'm getting the right ones. To get a closer look, I want to take this dial off. I've already loosened it up, but I put it back on because I wanted to give you guys an idea of how to get these off. So the dial itself is made out of some type of thin plastic. It's kind of translucent orange, and it's held on by this circular clamp here. The way you can get them off is to use something like small needle nose pliers, and you get them into these 2 holes, and you rotate it, and after about a quarter turn it will come out, and it reveals the tuning dial, which is keyed off of 2 holes. Very, very carefully loosen this up. It's probably going to be completely fused to the hub below from time, so I found a straight edge razor blade is a good tool to get in between the 2. I've already loosened this one up, so it should pop right out. And then be careful to slide it off of these 2 points up here. These are just dimples in the steel mounting frame that rub against the dial to keep it in place. And there it is. Mine's got a crack in it, but I'll use the one from my other set. Below it we can see this interesting piece of plastic, and what this is a way to illuminate the correct band. This has 4 bands on this radio. Behind that there's a light source up there, and there's another piece of plastic behind that rides on the band switch, and it will cover up and only let light through on the proper band. Now what I wanted to get at was these mounting grommets below. So I'll take out a ruler and measure those and make sure I get the right ones. When I get them in, I'll have to carefully unsolder the braids going to the capacitor and any other leads. Then I can remove the 3 mounting screws, take the whole thing out, put the new grommets in, and then put it all back together. It really is worthwhile though, because without it, when you go to rotate the tuning dial, this whole thing really moves around. Now that I've got it open, you can get a better look at that weird tuning mechanism I mentioned in the earlier video. So here's the fine and coarse tuning. And inside here, I'm sure there's some ball bearings. Actually, I know there are because I already took one of these apart. And when I put it back together, it wasn't working quite right. The problem, I believe, when I put my other one back together was this mechanism back here. In addition to the planetary drive in here, there's also this hoop. So this shaft does not actually go into the tuner. It goes into this shaft back here, which has a spring tension on it, and then a gap where the hoop sits. And when you turn this, it makes the bottom of this hoop turn, and the top of that is what actually drives the tuning capacitor. But this one is all really seized up, so it just barely turns. So while I got it open, I'm going to shoot a little bit of WD-40 in here and see if I can work the mechanism loose a little bit better. I made a little protective shield with some paper towel, and I carefully shot some WD-40 right in there, right down in here, and down in here. I'll let that sit for a little while and then see if the shaft loosens up. Alright, 3 cheers for WD-40. After about 10 minutes I gave it a try and it's actually moving quite smoothly. It would be nice to completely take this apart and flush all the old grease out and such, but like I said, having done this once before, I know how much of a pain it is, and this is working just fine. Now what I will do is flush a little bit more with the WD-40 and blot out all the excess as best I can, and then try to feed in a little bit of new grease. So the outer one is coarse, and you can see as I just turn this a little bit, the inner knob turns quite a bit. Likewise, if I turn this one, the outer knob moves very slowly. And here's that crazy mechanism. I think you can get a better look from this side. So the knob is not connected to the capacitor shaft. It's connected to this hoop, which I imagine serves as a bit of a gear reduction. Alright, so I placed my order, and as soon as these new mounts come in, I'll tackle this assembly. The speaker I won on eBay showed up today, but unfortunately it has suffered some damage. There's a pretty bad tear there, another tear on the other side, and it's crumpled over here. And as I showed in the picture on eBay, it looked rather pristine. What I think happened was that the seller overpacked this. All this material was in there, and I think what happened is some of this bubble wrap was placed against the cone, and it actually pushed through, because the box wasn't damaged, so I don't think it suffered any damage in shipping. I think it was just it was the packing material itself mashing into the cone. If you're going to ship a speaker, you should really just take a thick piece of cardboard and put it over that, and maybe put some twist ties through the holes. There's no reason to put any kind of foam or peanuts or anything actually pushing against the cone itself. Well, I paid a whopping 99 cents for it, so oh well, I can repair it. Otherwise it looks to be in good shape, and I think the dimensions are right. My order from Renovated Radios also showed up with the rubber mounts for the tuning capacitor, so I get that in there so it won't flop around like this anymore. It'll also solve another problem I discovered, which is when you tune this, because this is sunk down, this tuning dial actually scrapes against the band switch, so once this gets lifted up, it won't rub anymore. Here's a side-by-side comparison of this permanent magnet Philco speaker to a field coil Philco speaker from about the same vintage. So, in this, field coil speaker. There's a large coil of wire here that creates an electromagnet when current is passed through it. They often use this as a filter choke in the power supply as well. And then there is the output transformer. So you would send a large voltage through this coil, and this has a high impedance connection that would go to your output tube, and this would transform it from a high impedance to low impedance to power the voice coil down in there. Now this is for a farm radio, and they don't want to waste current and drain the batteries by powering a field coil, so they go with a permanent magnet. But back then they did not have the type of high-powered rare earth magnets that we have today, so that's a fairly large magnet, but it's actually kind of weak. So there's a piece of steel, and it's really not a very strong magnet. I guess today they use neodymium and cobalt and such to make much stronger magnets. This is probably just iron, maybe iron nickel. So this obviously doesn't have that field coil connection, just an output transformer. And it sure looks to me like this connector will fit into the radio. Yep, sure does. And here's the remains of the old plug that came with the radio, and it is identical. Now, one confusing thing about this, on the schematic for the 643, they say that the output transformer is mounted on the speaker frame, just like it is with this speaker. This guy down here. However, when I traced out the wiring on this chassis, this is the output transformer. And the plug that came with this radio only has 2 wires connected to it, and there's only 2 wires going to this plug. So perhaps there was a design variation in which the output transformer is on here, in which case I do not need this transformer. I can just bypass it, because there are 3 wires going to this plug, and only 2 of these actually have anything connected to them, so this is definitely not going to work as is. I'll have to be a little bit careful when I try this out though, because I don't want to fry the voice coil on the speaker. Can't show it to you because they put this safety mesh around the back side, which theoretically would help protect the paper cone from being damaged, because you can't poke anything through from this side, but unfortunately didn't protect it in this case. So I've done a video in the past on how to repair speaker cones, and I will use the same techniques. Well, I will use some diluted fabric glue and a brush and work it into this paper and glue up the seams. Unfortunately, having these screens in place is a hindrance to me repairing the speaker cones, because I need to push it from the back side because it's crushed in right now. I need to push it back. So I think I'm going to have to peel some of this stuff off. I imagine this adhesive is pretty worn, so this will probably peel this off without too much trouble. Yeah, I was right. This screen just practically fell off. I just grabbed one corner and picked at it and it fell right off. And it's just as well that I removed it, because this is all rust. That adhesive must have attracted some moisture to it and really corroded this. So I think I'll take them all off and remove the rust. But now I can push that cone back into place from the back. And down in there we can see the voice coil. Speaker seems to be okay. It's moving. I don't hear any rubbing, scraping. Hopefully it's a good speaker. So if I'm right, and the output transformer is in the chassis, I guess I would connect my cable directly to these 2 points. I was able to repair those tears in the cone using some Eileen's tacky glue, diluted a little bit in some water, and a soft brush to apply it. I also used a little bit of painter's tape on the back of each major tear to hold it together while the glue set up. But I did not need to use any patches, just work the glue into the paper fibers and they stitched themselves back together. And it's pretty strong now. For a little test here, what I'm going to do, or what I have done, is I unsoldered the lead going to the voice coil of this speaker. And I got a couple alligator clips going to them, and I'm going to run over to the speaker's voice coil. This speaker is going to the Motorola TV chassis I've been working on lately. If I had an audio oscillator with decent output, I'd use that, but I actually don't. All my generators are actually in the RF range. So, one there, and one here. Alright. Sounds pretty good to me. Alright, so one more piece of the puzzle falls into place. Now, if you're wondering how am I going to power this DC farm set, well, I've been noodling around with that, and I'll show you some schematics I've been working on. This schematic I found on Nostalgia Air actually lists the battery consumption. So there's the A battery, that's the filament, and it says 0.750 milliamps. That's wrong. It's 750 milliamps or 0.75 amps. I imagine that was a typo. And for the B battery, they have 22 milliamps, which is correct. Just for curiosity's sake, what I did to verify this number is I went through all the tubes and looked them up in the tube manual to see what the filament current consumption was. And yeah, it adds up right to 750 milliamps. And I'll just trust their value on the B battery. They don't list the C, which is the bias, because it draws so little current, it's not even worth mentioning. So now I know I need 2 volts at 0.75 amps and 135 volts at 22 milliamps. So that's enough to get me started. So I started noodling around and went through a few permutations and finally came up with this. So let's start at the bottom here for the bias supply. So secondary off of an AC transformer, bridge rectifier with the positive grounded and the voltage taken off of the negative. So this is a negative voltage here. That's why I have the filter cap upside down with the plus going to ground. Then a resistor of a to be determined value, and then some Zener diodes. I'm not sure if I can get exactly 4 or exactly 3.5. But I hope I can get something pretty close. So the idea is the current will flow through here to the load, and down here through the Zener diode to this load, and then finally down to this Zener diode. So you need to pick R such that it provides enough current through here to form stable voltage points. Taking into consideration the load here. Now I know this load's going to be very, very low, so I would imagine I can pretty much disregard this current entirely, which will help me figure out this value. But I also need to know what the voltage is going to be here to do that. It needs to be more than 7.5 volts for this arrangement to work. So say something around 10 volts and negligible current draw, so there'll be about 2.5 volt drop across here. And you work out with currents and so on and find that R value. Anyways, that's pretty simple. The 2 volt, that you want to be pretty stable, because if it goes over 2 volts, you can burn out all the tubes. So here again, bridge rectifier, negative grounded, positive going through a pi filter to provide plenty of good filtering on that. And then for this, I will use a modern voltage regulator. The LM317 is an adjustable positive voltage regulator. It has a range, I think, of 1.2 to 37 volts. You set the output voltage with these two resistors. So again, I'll do a little more math there, but shouldn't have too much trouble. If I get around 5 to 7 volts here, should have no problem getting 2 volts out here. Which leaves me with the B plus, the 135 and the 67.5. For that, I'm going to use a center tapped secondary high voltage winding, ground the center rather, and make a full wave rectifier, and then again Zener diodes. I'll need a dropping resistor here. I did look up these Zeners, and the closest I get is 68. There is no 67.5 that I could find, but 68 is pretty darn close. So a couple 68s will give me 68 and 136. Now, it just so happens that I've had this transformer for years. I think I took it out of some military surplus equipment, and I did design this circuit with this transformer in mind. So very conveniently, I've got a 6.3 volt at 1.2 amp secondary. That'll give me my 2 volt at 0.75 amp A supply. No problems there. There's a 6.3 volt at 0.6 amp. We use that for the C bias. And finally, for the B plus, I've got a 500 volt center tap at 10 milliamps. Now, that's a bit more voltage than I need and a bit less current than I need, but I believe when you hook this up in a full wave configuration, that translates to more like 250 volts AC at 20 milliamps. And after you rectify it and filter it, this should be a filter cap here, it'll give me in the ballpark of 250 to 275. And I'm hoping the transformer can handle the 22 milliamp load without too much dropout, especially considering I won't be putting in much of a load on the 2 secondary windings. So it'll involve a little bit of experimentation to make sure it's all working right. So I'm going to need to order a few parts. I don't have these Zener diodes on hand, and once I do, I will point-to-point wire this up to make sure it's working right, and I'll put on dummy resistive loads to make sure the voltages work out right. But for the time being, that is my plan, and I think that is enough for tonight. I will pick up later when I think I'll be ready to do more refinishing after that grain filler dries.